All right, before I start, I think it was quite fun and great to notice that the governor here mentioned fusion power and the announcement that Microsoft and Helion made yesterday with the promise to deliver fusion power 2028. Are you aware of the magnitude and potential impact of fusion power? I mean, it's actually the power of the universe. All power we use here comes originally from fusion power. I mean, I've always been interested in fusion. 3 years ago, I knew some of it, but I mean, there were some really revolutionary facts that I was not aware of. Do you know that one bottle this size of water, if you convert the hydrogen in that water into helium through a fusion process, through fusion power, the power released there is enough to produce electricity for your whole life. And looking at where we were in the 1950s when it comes to fusion power development and to where we're today, we have improved 10,000 times. 10,000 times, that's quite impressive. We're talking about Moore's law here. And it's just 5 to 10 times left until fusion is feasible. What's going on right now? Fusion has entered from research into industrialization. And when I met John Jäderberg 3 years ago, that completely changed my life, and we founded Novatron Fusion. I don't know if you know that much about fusion, but the key challenge, you know about the key challenge in fusion? I mean, we want to mimic what's happening in all the stars and in the sun. So we need to keep a really hot gas in place without leaking. So we need to create a micro-universe here on Earth where we keep this really hot gas in place. We're talking about 115 million degrees to mimic what's happening in the center of the sun. And we want to do that long enough without leakage. That's a pretty big challenge. All right, Jan has solved that. And before I come into that, I'm going to say a few words about Jan, this inventor. His first invention, he's a really amazing guy. You recognize these things? CD disk. So to produce a good CD disk, you need a thin layer of metal. And Jan's first invention was to, through actually a plasma technology, create a layer that was 100 atom thick plus minus 1 atom. Pretty amazing. Another great invention he did is actually when you produce the screens to these computers, you need to heat up a surface with extremely high accuracy. And he developed the world's most advanced induction production technology. And you know which was the first major investor in that company? Microsoft Corporation. And this guy that does not come from the fusion industry. I mean, he's an engineer, inventor with a lot of knowledge. He's got black belt in plasma physics for industrial application and in magnetic fields. He came from outside looking at what everybody else had done since the 1940s when they started this and saw it from a physics perspective and saw, I mean, it doesn't work yet. The problem is not solved. It doesn't work good enough now. Can't we do it another way? And then he had this eureka moment listening to Mozart's Requiem, I've heard. And he realized, wow, this must work, but I'm not sure. So he started to talk to professors in Sweden, all around Sweden, and went a little outside Sweden. And after a while, they pointed to the US because you have a lot more research and knowledge and have a lot more money to develop fusion here. And he came to this professor, Ken Fowler, a professor emeritus at Berkeley. He was the one that led the big fusion projects in the 70s and early 80s here in the US, and was part of starting the world's biggest fusion project, ITER. And when he looked at this, he said, the Novatron fusion appears to be the missing link. Today, we continue, of course, to collaborate with him and other people in this area in Berkeley and Lawrence Livermore. All right, are we the only solution out there? Of course not. I mean, we've been working this for quite some time. And there are some issues, of course. I mean, as I mentioned earlier, that the problem is not easy keeping a plasma in place at these temperatures. So far, the most successful way to encapsulate a fusion plasma is with something that gets to the shape of a donut or of a bagel. The thing is, if you have magnets around here and you put the plasma, the microsun, the sun will have this shape then. The thing is, when they are in there, they will spin around, and after a while they will not stay there because it's not stable. So it needs to be start, stop, start, stop, start, stop to work. And none of the other solutions that is out there are actually inherently stable. They cannot run continuously. And this is what Jan brought to the table. So the shape of our sun is the shape of an apple cart. And all the surfaces are concave, which means that the sun, all the particles in our sun, when they escape, they encounter a stronger and stronger force that will push it back in all directions, which is not the case of any other known solution. And the benefits of this is that you have a stable confinement. You can have a continuous fusion process. And it's actually so geniusly designed with the magnets that it's completely symmetric, which means it has a lower complexity than other solutions, which means it's easier to industrialize. And talking about industrialization that we're aware of, with the Microsoft statement and Helion statement, that this is really ongoing now. I mean, we're about 40 companies working towards the same goal, to get fusion power to the grid. Just in the last few years, more than $5 billion have been invested in these companies, and more is coming in. We see that nations are putting fusion as a national strategy. The Congress here has said that fusion power is a national priority for the US. Your neighbor Canada has already implemented a national fusion strategy. UK has implemented a national fusion strategy. This is happening now. They see this not as a research project, this is industrialization. And we also see that these companies popping up like ours, we need to collaborate. So we have started Fusion Industry Association. In the UK, at the Culham, which is the world's biggest plant for fusion collaboration, they've started the Fusion Cluster to encourage even more collaboration, which we think is great. To ease regulation and to standardize, to make this go faster. And a few years ago, in the Times feature article in the Times magazine, it was stated that nuclear fusion is the greatest antidote to climate change that the human race could reasonably ask for. Because fusion can deliver clean, fossil-free energy at an affordable price 24/7 with the fuel that comes from this. And we have a lot of that. All right, so we at Novatron, we're building our first plant right now. And as I told the governor, I talked with him a few minutes ago, that this will be the hottest place in Sweden and the hottest place in the Nordics by far. And we are here to find partners, to find financial partners, to find competence to do this sooner, to do this faster. Thanks a lot for having me.